Inside every atom there is something terrifying, and most people walk through their entire lives never realizing it, because atoms look harmless, silent, invisible, almost peaceful. Yet when one is forced to break apart, it releases a level of power that once turned cities into shadows burned onto concrete. And that same process now quietly boils water to light millions of homes around the world, which means the line between progress and destruction is thinner than anyone likes to admit. And the disturbing truth is not just that atoms can explode, but that when you split one, a tiny piece of matter simply disappears and becomes pure energy, as if reality itself is not as solid as it feels. And that discovery changed science forever, because it proved that the world around you is not truly solid, but compressed energy waiting to be released under the right conditions. And in this video you will learn what really happens inside the nucleus during nuclear fission, why a small particle called a neutron can trigger a chain reaction that multiplies in less than a fraction of a second, how the equation discovered by Albert Einstein revealed that mass and energy are interchangeable, why early scientists were both excited and deeply afraid of what they had uncovered, how this knowledge led to the creation of weapons developed under the leadership of J. Robert Oppenheimer, and why even today thousands of nuclear warheads remain active across the planet long after the first mushroom clouds rose over Hiroshima and Nagasaki. But beyond the history and beyond the explosions, there is a deeper and more unsettling layer that rarely gets discussed, because splitting an atom reveals that matter itself is mostly empty space held together by powerful forces, that the nucleus is bound by what physicists call the strong nuclear force, which is one of the most powerful forces in the universe, and that when this force is disrupted, a small fraction of mass converts into energy, according to E equals mc squared, and even a tiny amount of mass can produce an enormous release of energy, because the speed of light squared is an unimaginably large number, which means the energy hidden inside ordinary material is far greater than the chemical energy from burning fuel. And that is why nuclear reactions are millions of times more energetic than traditional explosions. And yet the truly disturbing part is not just the scale of power, but the implication that everything you touch, every object around you, even your own body, contains this compressed potential, quietly stable only because the forces inside atoms remain balanced. And the moment that balance is disturbed under the right conditions, a cascade can begin, where one split atom releases more neutrons, which split more atoms in a self-sustaining chain reaction. And in nuclear reactors, this reaction is carefully controlled with rods that absorb excess neutrons to prevent runaway energy, while in atomic bombs the reaction is designed to escalate uncontrollably within microseconds, creating temperatures hotter than the core of the sun. And during the early days of nuclear research, some scientists feared that testing such a device might ignite the atmosphere itself, a fear later calculated to be unlikely but serious enough that it was discussed, which shows how little humanity understood the forces it was about to unleash. And in this video, you will also learn about the hidden cost of nuclear fallout, how radioactive isotopes linger long after an explosion, how radiation damages cells by breaking DNA strands, and how entire generations carried the physical and psychological scars of nuclear testing. Yet at the same time, nuclear energy remains one of the most efficient low-carbon power sources available today, creating a complex reality where the same scientific breakthrough can either light a city or erase one. And this dual nature is what makes splitting the atom so unsettling, because it exposes how thin the barrier is between creation and destruction, how knowledge itself can be both salvation and threat, and why understanding the true mechanics behind atomic fission matters more than ever in a world that still depends on nuclear technology. And by the end of this video, you will clearly understand what physically happens at the subatomic level when a nucleus fractures, why mass is not as permanent as it appears, how close early experiments came to outcomes scientists barely understood, and why the real disturbance lies not in the explosion, but in the realization that reality is built on forces far more intense than human senses can detect. So stay with us until the very end, because the final section will connect atomic fission to a bigger truth about the structure of the universe that changes how you see the physical world around you. And once you grasp that truth, ordinary matter will never feel the same again. Welcome to the channel where science is explored with clarity and depth. And if you value thoughtful explanations that reveal the hidden side of reality, subscribe now and join us as we continue uncovering the powerful secrets shaping our world. An atom is so small that billions of them could sit on the tip of a pencil and still be invisible, yet every wall, every ocean, every mountain, and every cell in your body is built from these tiny units, which means the solid world feels large and heavy only because uncountable numbers of atoms gather together and move in patterns that give the illusion of firmness and weight. And for a long time people believed atoms were the smallest possible pieces of matter, indivisible and final, as the word itself suggests, but science kept digging deeper and discovered that even atoms are not simple, because inside each one there is a dense center called the nucleus, made of protons and neutrons, and around that nucleus, electrons move in regions that are mostly empty space, so empty that if the nucleus were the size of a marble, the nearest electron would be hundreds of meters away, which means most of what feels solid is actually space structured by forces, and protons carry positive charge while electrons carry negative charge, and neutrons carry no charge at all, yet play a critical role in holding the nucleus together. And these particles are bound by fundamental forces that are stronger than anything experienced in daily life, especially the strong nuclear force, which acts at extremely short distances, yet overpowers the electric repulsion between positively charged protons packed tightly together in the nucleus. And from the outside, atoms seem calm and stable and harmless, forming the air you breathe and the ground you stand on without noise or drama. But stability does not mean weakness, because inside that tiny nucleus, enormous energy is locked away, held in balance by forces that took shape in the first moments after the universe began. And the reason this energy exists is tied to how mass and binding energy work together. Because when protons and neutrons bind into a nucleus, a small amount of mass is converted into binding energy that holds them together. And that energy remains stored until something disrupts the balance. And when a neutron moving at the right speed strikes the nucleus of certain heavy atoms, such as uranium, the nucleus can become unstable and stretch and split into two smaller nuclei, a process known as nuclear fission. And when this happens, it does not simply break quietly. It releases additional neutrons, along with a sudden burst of energy, mostly in the form of kinetic energy and radiation. And those released neutrons can then strike other nearby nuclei, causing them to split as well. And this sequence forms what is called a chain reaction, where one split becomes two, and two become four, and four become eight, multiplying at a rate that grows rapidly in an exponential pattern. And in a controlled environment like a nuclear reactor, engineers use control rods made of materials that absorb neutrons to keep the reaction steady, so energy can be released slowly and converted into electricity. But if the reaction is left uncontrolled and enough fissile material is present in the right configuration, the multiplication accelerates violently, and all of this unfolds in less than a second, faster than conscious thought, faster than reaction time, a cascade of atomic fractures that transform microscopic changes into massive energy release. And the disturbing part lies deeper than the blast or the heat, because when scientists calculated the energy output, they realized it came from a tiny loss of mass, a fraction so small it seems impossible that it could matter. Yet according to the equation developed by Albert Einstein, E equals mc squared, even a minute amount of mass converted into energy yields an enormous result, because the speed of light squared is an extremely large number. And that means when a nucleus splits and the total mass of the fragments is slightly less than the original mass, the missing mass has not vanished without trace, but has been converted into energy. So, matter itself is not fixed and permanent, but interchangeable with energy, and this reveals that what feels solid and enduring is actually a condensed form of something more fundamental, a reservoir of force, bound tightly by physical laws, and solid matter is not truly solid in the way human senses interpret it. It is structured energy, compressed and stabilized, and when the compression changes even slightly, energy flows outward, and this leads to the unsettling realization that every object around you contains far more energy than chemical reactions ever release, that the difference between a peaceful stone and a devastating explosion lies only in how the atomic nuclei are arranged and whether the binding forces are disturbed. And this understanding did not appear overnight, because early atomic theory treated atoms as indivisible building blocks, until experiments by physicists in the late 19th and early 20th centuries revealed subatomic structure and radioactivity, and as knowledge advanced, the implications became clear to a generation of scientists, including Robert Oppenheimer, who later directed the scientific effort that produced the first atomic bomb, and the realization that humans had accessed star-level processes brought both awe and dread, because nuclear fusion powers the sun, while nuclear fission unlocked comparable forces on Earth. And when the first test explosion lit the desert sky, it confirmed theoretical predictions but also marked a turning point in human history. And when bombs were dropped on Hiroshima and Nagasaki, the scale of destruction shocked the world and introduced a new era defined by nuclear deterrence and fear. And from that moment forward, political power and scientific knowledge became tightly linked to the control of atomic energy, and the phrase that humans had split the atom became symbolic of crossing a threshold that could not be reversed, because thousands of nuclear warheads were eventually built and stored across different nations, each one capable of unleashing energy derived from the same principles that govern the smallest particles, and at the same time nuclear reactors spread across countries to generate electricity, using the same chain reactions but managed carefully to prevent runaway conditions, and this dual use continues today, with nuclear power plants operating under strict safety systems, while nuclear weapons remain part of military strategy. And the unsettling fact remains that the energy contained in a small amount of fissile material can level a city, and that energy originates from the binding energy inside atomic nuclei. And this leads to a philosophical layer that reaches beyond physics, because the universe appears calm and stable at everyday scales, while hiding immense forces at microscopic levels, and stability depends on balance, and balance can shift under certain conditions. And if atoms hold that much energy locked within their cores, it raises deeper questions about the layers of reality still unexplored, about what lies beneath protons and neutrons, which themselves are made of quarks bound by gluons, about whether deeper structures hold even greater forces, and about how much of the universe remains hidden simply because current technology has not yet reached the required scale. And it challenges the assumption that what feels solid and permanent is truly fundamental, because each new discovery in physics has revealed that beneath every layer there is another, and that knowledge expands power along with responsibility. And as research continues into high-energy physics, particle accelerators, and quantum fields, the pattern remains consistent, that unlocking smaller scales often reveals larger implications. And if the splitting of the atom reshaped geopolitics and ethics within a single century, it raises questions about how future discoveries might transform society again, and whether humanity can match its technical capability with equal wisdom, because the same curiosity that drives exploration also opens doors to consequences that cannot be undone, and the awareness that every person is composed of atoms containing locked energy reframes the sense of solidity and permanence, suggesting that existence is a delicate arrangement of forces balanced in dynamic equilibrium. And this awareness continues to influence physics, philosophy, and global policy as the world lives with the legacy of atomic discovery and the knowledge that within the smallest structures lie powers once thought reserved for stars. Inside the air you breathe there is sleeping power, quiet and invisible, drifting past you every second without sound, without light, without warning. And inside your body there is star-level energy packed into atoms that were forged long ago in ancient stars before the Earth even existed. which means you are not just standing on a planet, but walking proof of cosmic forces held together by delicate balances inside trillions upon trillions of nuclei. And for most of human history, that power remained locked away, hidden behind the illusion of solid matter, until science uncovered the truth that atoms are not indivisible, not simple, not harmless, but dense knots of energy bound by forces strong enough to reshape cities when released. And once humanity discovered how to disturb that balance, there was no turning back, because splitting the atom was not just a scientific milestone, it was a moment that changed how we see reality itself, revealing that what feels stable is actually tension held in place, that what feels permanent is structured energy, and that even the smallest fragment of matter carries within it a force far beyond everyday experience. And this knowledge continues to define the modern world, from nuclear power plants generating electricity to arsenals that still exist as reminders of how fragile global stability can be. And the deeper truth lingers beneath it all, that matter is not solid in the way our senses suggest, but condensed energy shaped by fundamental laws. And that realization is both beautiful and unsettling at the same time, because it connects you to the stars, while also reminding you how thin the barrier is between calm and catastrophe. And as you step outside after watching this, the ground beneath your feet and the sky above your head will be made of the same restless building blocks, quietly holding immense force. And the disturbing part is not that we can split atoms, it is that we now understand what matter truly is, and what that means for our future. So if this changed the way you see the world even slightly, support the channel by subscribing, like the video to help more people discover these hidden truths, and share it with someone who loves exploring the deeper layers of reality, because the more we understand the forces around us, the more carefully we may choose to use them.